Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera to all of you. Okay, today we will discuss chapter 6, circular motion. Before we discuss the question in chapter 6, okay, I would like to brief just a simple concept in chapter 6. Okay, before you answer any questions that related in chapter 6, you need to identify the type of your plane for the circular motion. Either your object move in vertical plane, okay, or in horizontal plane. Okay, ini penting. Bila you dapat soalan, you kena tahu objek dia travel in circle sama ada vertical atau horizontal. Okay. And after that, you need to know how to sketch the free body diagram lah. Okay, we will discuss later. Alright, and the equation in this chapter, we have S equal to R theta. And the other one, we have V equals to R omega. Alright, so what is S? S is the displacement and the unit is in meter. And theta is angular displacement. Okay, and unit is in radian. Angle. Angle adalah degree sepatutnya kan. Tapi unit kita adalah radian. Bukan degree ya. Okay, so ingat. S is the displacement. Unit is meter. While theta is angular displacement. Unit kita adalah radian. Okay. For the V. Okay, V as usual is the velocity and the unit is meter per second and omega. Okay, symbol is omega and the name for omega is angular velocity. So the unit is rad per second. So dekat sini kita boleh nampak lah. Hold on. Okay, which is velocity, unit is meter per second, angular velocity rad per second. Okay, so actually this is the relationship, okay, relationship between, okay, between linear motion and circular motion. Okay, S stand for linear, theta tu adalah circular. Velocity yang ini untuk linear motion, omega ini angular velocity you untuk circular motion. Okay, next. Okay, next you need to know the definition of centripetal acceleration. Okay, and the symbol of centripetal acceleration is AC. Okay, in bahasa Melayu dia adalah the pecutan memusat. So what is the centripetal acceleration? Okay, so centripetal acceleration is the acceleration of an object okay, that moves in circular path. Okay. And directed towards to the center of circle. Okay, so that's the definition of centripetal acceleration. And what is, okay, what is the equation? The equation is AC equals to V square over R. And the unit, okay, and the unit for the velocity is meter per second. Okay, meter per second. But then you have the V square. Okay, so when you have the V square, maksudnya ini kena square lah. Okay. Alright. Nak bagi tahu, awak kena buat dia dalam SI unit. Ini ada square kat sini. This one. Okay. And R is the radius, also in meter. That's why the unit for centripetal acceleration adalah meter per second square. Okay, dia standard, biasa sahaja. Now, the second definition is centripetal force. Okay. In bahasa Melayu adalah daya memusat. Okay, because dia encircle kan. Okay, so what is the centripetal force? Okay, centripetal force is the net force, ya. Okay, net force or total force. Okay, total force required. Okay, total force required to keep an object moves with a speed in circular path. Okay, in circular path. Okay, and what is the equation? Okay, we will use the Newton's cycle of motion, which is Fc equals to MAC. Because Fc ini adalah kita punya total force. Okay, where's your AC? That's your Fc. Kita kena tengok dekat mana arah AC awak. Okay, dekat mana arah AC, dekat situlah arah Fc kita. Yeah. Alright, and the unit for force as usual, it is Newton. Right? Okay, that's it. Okay, let's discuss our first question. Okay, our first question. A 0.2 kilogram ball attached to the end of a string is rotated in horizontal circle of radius 1.5 meters on a frictionless table surface. Okay, the string will snap when the tension exceeds 50 Newton. Okay, so first of all, kita baca soalan. Oh, it is given in horizontal circle. Okay, it had mentioned in the question. Okay, jadi kita list out all the information given. The first thing is we have the mass of the ball, which is 0.2 kilogram, and you have the radius of the circle given is 1.5 meters, and you have the tension. Okay, the tension is 50 Newton. More than 50, the string will snap. Maksudnya dia akan terputus lah. Okay, jadi tension ini adalah tension yang maksimum, ya. Okay, next what should you do is you need to draw a simple diagram. Okay, we know that it is rotate in horizontal circle. Okay, in horizontal circle. So this is the center of the circle, and this is the string, and that's your ball. Okay, now you need to identify all the types of forces that acted on the ball. Okay, kena lukis dulu baru kita tahu macam mana kita nak solve dan sebagainya. Okay, so this one because the ball placed on a table surface, jadi you will have the normal. We have the normal, Okay. Okay, so that's the normal, and this is the weight, always directed towards the center of the earth. And lepas tu, because string awak ni akan ada tension lah. Okay, because it is a string, akan ada tension. Okay, alright, settle. So we have these three types of forces. Okay, so normal ada sebab ada contact surface, ya. Okay, lepas tu kita tengok soalan. Okay, A, dia tanya, what is the maximum speed of the ball? Okay, means you need to determine the V of the ball. Okay, V of the ball. Okay, so to find the V, it is related with the centripetal acceleration, which is V square over R. But then you need to identify which force become as your centripetal force. Yang mana yang jadi net force kita, iaitu centripetal force. And kita boleh nampak what is the function of the string. Okay, string adalah to make sure your object can whirl in circle. Without string, tanpa tali awak, kalau tali tu putus, dia pergi tempat lain. Okay, jadi yang penting sekarang ni ada tali, maksudnya akan ada tension. So, tension acted as your centripetal force. Okay, if you want to label the direction of AC also can Okay, jadi kita dah tahu, oh, AC always directed to the center of circle. So, that's your AC. Okay. Please label outside tau. Okay, please label outside. Outside tu maksud saya, kalau ini awak punya tension, okay, so that's your tension, buat acceleration tu dekat luar. Okay, because tension and acceleration dia benda yang berbeza. Satu force, satu acceleration kan. Okay, so dia benda yang tak sama. Jangan buat macam ni. Okay, jangan buat macam ni. Jangan together-together. Tak boleh. Okay, ini salah. Okay, salah. Please don't do that. Okay, now proceed. Alright, so we can see that your F net, which is your FC, equals to MAC. So FC is the tension, and you can change as AC into V square over R because you want to find the velocity, right? Okay, so kita check. Okay, check all the parameters. Okay, we have the tension, we have the mass, we have the R. So you can substitute all the values lah. Okay, so tension is 50. Okay, and mass is 0.2. Okay, times with the V square over with R. Okay, so saya over R pula. Sorry, over with R is 1.5. Okay, jangan sibuk nak tekan kalkulator terus ya. Okay, biar lambat asal selamat. Kadang-kadang kerana awak punya careless mistake during using the calculator, so awak buat kesilapan yang sangat-sangat tak patut. Okay, so this one is V square equal to 50 times with 1.5, okay, over with 0.2. Okay, dah buat benda tu barulah. Okay, ini sebab saya boleh padam macam ni. Okay, so ini akan set, right? Okay, so you will get the answer as 19.36 meter per second. Okay, settle for maximum speed. Okay, because tension awak adalah maximum, jadi itu adalah maximum speed lah. Okay, now look at to the second question, B. Okay, if there were friction on the table, what will happen? Okay, what will happen to the maximum speed? Explain your answer. Okay, jadi kalau ada friction, apa pula jadi kan? Okay, jadi sekarang ini, the answer is, the maximum velocity, the maximum speed will be decreasing. Okay, will be decreasing. But why? But why? Sebab, okay, kita tengok kita punya equation. Okay, you punya equation is centripetal force equals to mv square over R. And we know that mass of the ball and the radius of the circle is a constant. Maintain, dia tak berubah pun. Yang berubah hanyalah surface. Okay. The first condition, frictionless. Okay, tak ada friction. Lepas tu ada friction pula. Apa jadi? Okay, so when the mass and the radius is a constant, okay, the centripetal force and the speed of the ball is directly proportional. So when you have the friction, means the centripetal force will be decreasing. That's why the speed also decreasing. Okay, simple. Question number 2. Sketch. Okay, you are given with this diagram. Okay, sketch the change in the velocity of an object due to position P and Q, which will show that the object is in uniform circular motion. Okay, so now this is about the concept here. Okay, so first of all, I will draw the circle. Okay. Number 2A. Okay, number 2A. And this is the point P right here. Okay, this is P. And this is Q. Okay. Now, you need to draw the direction of the motion at point P because it is rotate, right? Okay, so rotate. Jadi inilah you punya velocity at point P. So this is the VP. And this part is the VQ. Okay, it's the VQ. Okay. And now, you need to show this object is moving in uniform circular motion. And this is the center of the circle. Okay, the center of the circle. Okay, and for your information, everything dia adalah sebenarnya perpendicularly. Okay, perpendicularly. Ini perpendicular. Okay, ini perpendicular. That's why the velocity adalah tangent. Dia 90 degrees macam tu. Okay. Alright. So, I will take out the vector of the velocity. Okay. So, this one adalah our VQ. Hold on, I will change the color. Okay, so this is the VQ in this direction. Okay, and the VP I will change in this direction. Okay, in this direction. Like this. So, this is the negative VP. Okay, negative VP. Macam ni. VP directed to the right. So, it is a positive. Now, saya change dia directed to the left. So, negative VP lah. With the same magnitude. Okay, with the same magnitude. Okay. Ini konsep vector. Okay. And we will get your resultant. Okay, so inilah you punya resultant. Okay, dah pernah belajar kat sekolah kan? So, inilah the change of our velocity. Okay, that's the change of the velocity. So, based on this diagram, okay, the change of the velocity is actually VQ, okay, minus with the VP. Okay, minus with the VP with the magnitude of VQ is equals to the magnitude of the VP. Magnitude dia sama. Okay, magnitude dia sama. And, okay, therefore, the change of the velocity, perubahan dia constant. Okay, the change of the velocity is directed to the center of circle. Okay, sebab dia bulat. Sebab tu tadi, circle. Okay, so that's why just now saya cakap dia adalah tangent. Okay, the tangent. Dan saya bawa saya punya VP ni ke sini. Okay, saya bawa saya punya VP kat sini. Okay, so nanti kita boleh buat dia punya ni lah resultant dia. Okay, alright. Hopefully boleh faham lah. Okay, settle for A. Okay, look at for question B. A cyclist negotiates a curve at constant speed Is the cyclist accelerating? So ada penunggang basikal tengah rotate dekat satu jalan raya yang selekor pada speed yang sama. So dia tanya adakah penunggang basikal tu accelerate, okay, memecut ke tak. So the answer is yes. Okay, the answer is yes. Okay, but why? Okay, sebab sekarang ni, okay, cyclist, okay, moves with constant speed. But the direction of motion changes. Okay, changes. Why changes? Because ini about you punya curve road. Okay, curve road. So, because of the direction, okay, because of the direction changes, okay, therefore, it is accelerating. Okay, therefore, centripetal acceleration occurred. And towards to the center of circle. Towards to the center of curve. Okay. So ini adalah basic concept for uniform speed. Number 2C. A car is rounding a flat unbanked curve with radius 250 meters. The coefficient of friction between the tires and the road is 0.92. The first Roman, you need to sketch and label all forces on the car. Okay, so as usual, please list out all the information given. You have the radius 250 meters. And you have the coefficient of friction, which is mu, 0.92. Okay, then you can sketch a simple diagram before you draw the free body diagram, okay? Okay, so this is the car. And of course, you will have the weight that acted on the car and also the normal because you have the contact surface. Okay, and then you will have the frictional force between tires and the road. Okay, now you can answer the first Roman. Okay, sketch the x and y axis, and this is the weight directed towards the center and the normal perpendicular with the surface, and this is the frictional force, and the direction of AC is towards to the center of circle. Okay, because this is your center of circle. Dia kena ikut ya. Kenapa? Sebab itulah you punya net force. Now, the second Roman, you need to calculate the maximum speed at which the driver can take the curve without sliding. Okay, tanpa kita accident lah maksudnya. Okay, jadi yang kedua, you want to find the V. Okay, so we will use your previous free body diagram, which is the total force occur on x-axis, sebab itulah you punya direction of AC. Kita tengok AC kita ke mana. Okay, because AC awak occur in x-axis, maksudnya f-net kita untuk x-axis lah. Okay, so itulah you punya FC. FC equals to MAC. Okay, and who's be your FC right now? Okay, the static friction. So static friction equals to mv square over R. And if you refer to the list of information, you just have the coefficient and the radius. Jadi you kena convert lah. Okay, change you punya equation of static friction as mu n. Okay, so the frictional to mu n, coefficient multiply with the normal force, and ini adalah mv square over R. And I make it this one as my first equation. Okay, my first equation. Sebab tak boleh nak solve kan, jadi itulah kita punya equation nombor 1. Barulah kita compare, not compare, we use the second total force, which is untuk y-axis. Okay, this one untuk y-axis because you dah buat untuk x. FC awak tadi untuk total force in x-axis. Now kita solve untuk y lah pula. Di normal you ada normal. Okay, y-axis you have normal minus dengan weight equal to 0. Jadi normal kita equal to mg. So this is our second equation. Then I substitute number 2 into number 1. Okay, so it will become like this lah. Okay, which is mu s, normal is mg, equals to mv square over R. And you can cancel out the mass. Okay, mass of the car are not given. Okay, dia tak bagi. Jadi, kita boleh cancel lah. Jangan kata not enough information pula. Okay, jadi kita boleh substitute lah all the values. And mu s is 0.92. The gravitational acceleration 9.81. Okay, equals to, this one is the v square over with the radius. Radius is 250. Okay, saya sambung, tak muat lagi sambung kat tepi ni. Okay, so saya boleh cari saya punya v. This one is 250 times with 0.92 and then times with 9.81. Okay, and then you need to set it. Okay, kena setkan dia. So, kita akan dapat, okay, sila kira bersama-sama ya. So, the maximum speed is the 47.5 meter per second. Okay, lambat tak apa, lambat sikit-sikit jadi betul. Okay, look at our next question. Question number 3A. Calculate the centripetal acceleration of an object at the equator due to the rotation of Earth. You are given with the radius of Earth is 6.4 times 10 to the power of 6 meters. Okay, jadi kita keluarkan dahulu kita punya information given, which is our ada radius of Earth 6.4 times 10 to the power of 6 meters. Okay, and you kena cari centripetal acceleration. Okay, centripetal acceleration at the equator. Okay, equator adalah khatulistiwa ya. Okay, khatulistiwa. Macam Malaysia lah. Okay, so kita dah tahu to find the AC, very straightforward. You just use V square over R. Tapi sekarang ni, you tak ada value for the velocity. Okay, we don't have the velocity. You just have the radius of circle. Jadi sekarang ini, you punya V, you boleh tukar dia, change into V equal to R omega. And omega is 2 pi over T. Jadi dia akan dapat 2 pi R over with T. Okay. Sebab ini. Awak punya omega is 2 pi over t. Okay. Sebab tu dapat macam tu. Okay, barulah kita substitute in our main equation kita balik. Okay, kita tukar dia. AC is equal to, ini adalah 2 pi r over with t square it over with r. Okay, ini depends. You nak cari dulu one by one, nak substitute terus pun boleh. Okay, nak substitute terus macam saya buat ni. So, 2 times 2, you got 4. And then, ini adalah pi square. Ini adalah r square. Over with, okay, period kita pun akan square, ya. Okay, and ini over with r. Jadi, you can cancel one of your r. Okay, ini cancel, ini tinggal 1. Okay, jadi kita punya equation akan jadi 4 pi square r over with t square. Okay, barulah kita tengok, oh, okay, 4 and pi is a constant. And how about you punya period? Period ni pula, mana pula kita nak cari, kan? Okay, period yang ini. T kita ni. Okay, so T ini kita kena refer the word of equator. Okay, because equator, one day, okay, one day, satu hari equal to 24 hours. Okay, 24 hours. Jadi, kita boleh carilah dia punya period untuk satu rotation. Okay, jadi saya akan substitute. So, this one is AC equals to 4 pi square. Okay, and radius is 6.4 times 10 the power of 6. Okay, over with the period. Period kita adalah 24 hours times dengan 60 minutes times with 60 seconds. So, dia adalah 3,600 seconds. Satu hari, kan? Tapi jangan lupa kita ada square. Okay, sila tekan calculator. So, then you akan dapat 3.38 times 10 the power of negative 2 meter per second square. Itulah dia. Soalan senang je. Okay. Kena faham soalan. Okay, keyword kita dekat sini adalah equator. Kalau tak faham equator, habislah. Fizik ni kena faham perkataan. Okay, now look at to our next question, number 3B. Okay, number 3B, figure 2 show a 0.3 kg object attached to a horizontal rod by 2 strings, each of length 0.5 meter. The object is whirled with speed of 8.0 meter per second around the rod axis. Calculate the tension in the string when the object is at the lowest point. Okay, kita buat untuk lowest point dahulu. Okay, jadi as usual, please list out the information given. You ada mass 0.3 kilogram and you ada length of the string is 0.5 meters, and the last one you ada speed. Okay, you ada speed 8.0 meter per second. Okay. Alright. Jadi dia minta kita cari tension, kan? Jadi as usual, please draw you punya simple free body diagram. Okay, so kita nak cari tension. Okay, at lowest point. Okay, jadi kita lukis dulu the simple free body diagram. Okay, and we have the weight. Ni ya, yang weight ni kat bawah ni. Okay, we have the weight sebab dia nak lowest, kan? Okay, so ini ada weight and you ada tension right here. Okay, ada dua tension ya. Okay, T1 ada T2. Okay, so this one adalah you punya T1 and ini adalah kita punya T2. T2. Okay, then you need to find out the value of angle. It's up to you. Okay, terpulang nak guna angle contact with Y or X. Okay, so ini adalah saya punya theta 1, ini saya punya theta, sorry. This one is our theta 2 and this one is the theta 1. Okay, kena follow lah apa yang kita dah buat kan. Okay, and kita gunalah information yang dia dah bagi. Okay, look at this diagram. You are the length of the string 0.5 and ini adalah you punya radius because dia adalah in vertical circle. Okay, radius of the circle and ini adalah 0.6. Jadi kita boleh nampak ini 0.3 lah, half. Okay, so itu 0.3 meters and ini adalah 0.4 meters. Okay, so saya keluarkan saya punya triangle tu dekat sini. Okay, this one is 0.5 meters. Ini adalah 0.3 meters. And ini adalah 0.4 meter lah. Itu standard 3, 4, 5 kan. Okay, tak ingat, gunalah calculator. Ini adalah Pythagoras theorem. Okay, Pythagoras theorem. Okay, so dah settle. Kita boleh cari angle yang kita nak cari. Okay, katakanlah saya, okay, sebab saya sentuh part CY, jadi inilah yang angle yang saya nak cari. Inilah theta saya. Okay, so that's my theta, my angle. Okay. Okay, so saya akan cari saya punya sin theta. Okay, sin. Sin is opposite. Opposite is 0.3 over dengan hypotenuse. We will get 0.6. And kalau cos theta, saya tak cari theta macam tu tau. Okay, saya guna macam ni. Tak apa, nanti awak akan tengok kenapa saya buat macam ni. Okay, dia terpulang ya. And ini adalah 0.4 over with hypotenuse 0.5. So we will get 0.8. Okay, so sin theta 0.6, cos theta adalah 0.8. Okay, now barulah saya akan use saya punya F-net. Okay, but before that, we know the center of the circle is your rod. Okay, rod kita adalah center of the circle. Jadi inilah kita punya direction of AC. Ini. Towards to the center of circle. Jadi, in our diagram, the direction of AC is in this way. Dekat situ. Okay. Kenapa? Sebab saya nak tahu siapa yang winner, siapa loser. Okay. Jadi, sekarang ini saya akan use F-net equals to FC is equals to MAC lah. Okay, jadi we can see that direction of AC occur in y-axis. Okay, y-axis. Jadi siapa? Okay, siapa yang jadi centripetal force? Okay, jadi sekarang ini kita punya T1 and T2, okay, has the angle. Jadi sebenarnya you punya theta 1 dengan theta 2 ni ada value yang sama. Kenapa? Okay, sebab tension kita ni, tension awak ni, ini T1, ini T2. Okay, dia ada length yang sama, 0.5 and 0.5. Okay, you have the same length. So, bila same length attached with the same object, okay, same object, jadi value tension pun akan sama, value angle pun akan sama. Okay, harap-harap fahamlah. Ini saya padam. Okay, so ini pun saya padam. Okay, jadi you boleh resolve you punya T1 and T2. Jadi inilah you punya T1Y and you ada lagi satu, ini adalah T2Y. Okay, jadi you punya T1, okay, Y, because angle saya contact with Y. Okay, angle saya contact with Y. Jadi Y saya akan jadi cos lah. So T1 cos theta. Okay, plus with T2 cos theta 2. Okay, and minus with the weight because the opposite kan equal to mv square over R. Okay, jadi sekarang ni as I had mentioned earlier, T1 adalah sama dengan T2. Okay, theta 1 sama dengan theta 2. Value dia sama. Okay, so value dia sama, kita pun boleh inilah combine together. So ini akan jadi 2T, okay, 2T cos theta saja. Okay, 2T cos theta minus with mg equals to mv square over r. Okay. So, barulah kita boleh substitute. Jangan cancel you punya mass ya. Okay, kenapa? Sebab dekat sini tak ada mass. There is no mass for 2t cos theta. Tak ada. So, please do not cancel the m. Tak boleh. Marah cikgu maths awak nanti. Okay. So, barulah saya akan proceed. Okay, so ini adalah 2t and cos theta. Okay, cos theta adalah 0.8. Okay, yang saya cari tadi tu. Nampak tak? Kita terus buat kat sini. Sebab saya nak jimatkan ruang. Okay. Terpulanglah nak cari angle pun boleh. So, kena tulislah cos berapa angle dia. And then mass adalah 0.3. Okay, times with 9.81 equals to mass kita 0.3 and V square. Okay, V is 0.5. Jangan lupa square it over with the radius. Okay, radius which is yang kita dah dapat tadi tu. Iaitu 0.4. Okay, 0.4. Kita dah cari tadi, so kita boleh guna terus. Okay, 0.4. Okay, ni saya padam sebab saya nak guna space kat sini. Okay, so therefore you can get the value of tension equals to, okay, tekanlah calculator you. So the answer is 31.84 Newton. Senang je. Sebab tu kena faham. Yang penting lukis free body diagram. Okay, lepas tu kena tahu direction of AC tu ke mana. Jadi awak tahu siapa winner, siapa loser. Okay, winner loser ni follow you punya AC. Okay, next. Number 3B, second Roman. Okay, 3B, second Roman, we need to determine the tension at the highest point. Okay, highest point. Maksudnya kita kena ubah kita punya diagram, which is object U occurred at the top. Okay, dekat atas. Okay, so kalau dekat atas, kalau kita lukis sikit-sikit, okay, sini object U, sini U punya string. Like this. So, we know that inilah U punya weight. Okay, and ini you punya tension, ini you punya tension. Okay, itu pentingnya imagination kita tu. Okay, jadi kita kena okay, hold on, saya nak tulis kejap. Kita nak cari tension at the highest point. Okay, at highest point. Okay, so you need to draw your free body diagram. Okay, to make sure you have the correct calculation. Okay, so kita draw you punya direction. So you have the weight in this direction. Okay, towards the center of the circle, and ini adalah you punya tension 1, ini kita punya tension 2. Okay, and let's say ini saya punya theta 1, ini saya punya theta 2. Okay, and actually the value of theta still the same, sama je atas dan bawah ya, sama saja. So tadi kita dah cari kan? Okay, tadi kita dah cari. Okay, sekejap saya tulis balik ya, supaya kita nampak benda tu. Okay, just now saya buat sin theta equals to 0.6. And lepas tu cos theta equals to 0.8. Okay. So sebenarnya tak guna pun cos theta tu kan, tapi tak apa. Okay, so sekarang ini if you refer to your T1 and T2, ini juga you punya direction of T1Y, and ini juga you punya T2Y. Okay, sorry, T2Y. Jadi kita boleh carilah awak punya tension, which is the net force is your FC equals to MAC. So who's be your FC right now? Kita kena follow the direction of AC. Okay, bila objek kita ke atas, inilah direction AC kita kan. Tu yang saya conteng tu. So inilah you punya direction of AC. Okay, so FC is the T1 cos theta okay, T1 cos theta because Y saya angle dia sentuh dengan Y. Okay, so dia cos lah. Okay, T1 cos theta 1 plus with T2 cos theta 2 and plus with the weight equals to mv square over r. Dia hampir sama dengan yang tadi. Cuma ada beza sikit lah. So ini you have the same tension and the same angle. Jadi saya combine. So ini adalah 2t cos theta. Okay. Plus with mg equals to mv square over r. Okay, sorry. Sebenarnya kita tak guna pun sin ni. Okay, saya salah sebut tadi. Sin ni kita tak guna pun. Okay, sebab sin tu untuk paksi X case kita sekarang. Because angle kita sentuh paksi Y. Jadi kita hanya guna cos theta. Okay. Sorry, saya salah sebut earlier tadi. Okay, so ini adalah 2t. Cos theta saya adalah 0.8. Okay. And plus with mass kita adalah 0.3. Okay, yang dalam soalan tu. G adalah 9.81 equals to mass kita 0.3. And the V still 8. Okay, don't forget square it. Over with the radius masih sama, iaitu 0.4. Sama, tak ada perubahan pun yang tu. Okay, value tension saja berbeza, atas dan bawah. Okay, therefore you can get the value of tension. Okay, hati-hati tekan kalkulator Ini saya buat cepat tau, sebab tak muat space. Okay, so untuk solution awak sendiri, sila buat, sila fahamkan. Okay, so end up you akan dapat 28.16 Newton. So nampak tak value dia lagi smaller. Yang tadi 31.84, yang sekarang ni 28.16. Okay, that's it for chapter 6. Okay, jadi soalan-soalan yang lain tu silalah jawab. Ada masalah boleh tanya pensyarah awak. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.